Number 3, describe the charge and location of each subatomic particle. Then label the 5 parts of the atom. So first we're going to just describe the charge and location of each particle. Okay? The proton. What is the charge of the proton? And where is it located? Riley? Very good. It's located in the nucleus and it is positively charged. Okay? If you have a hard time keeping those straight, I do recommend that you highlight or circle the P in proton and the P in positive. Okay, protons are the positively charged particle, and they are located in the nucleus. Ian? Yes, electron. Very good. Negatively charged particle, spinning in the shell. The electron is the negatively charged particle spinning in the shell. Okay? And then the neutron. Aiden? Very good. Yes. Yes, it would. From what I can tell. Okay, yes, the neutron is the neutral particle, meaning it doesn't have a charge. It doesn't really pick sides. It's just kind of, it doesn't have positive or negative. It's neutral. And it's located in the nucleus. Again, if you need help kind of keeping those straight, underline the NEU in neutron and the NEU in neutral. That's kind of your clue. Neutrons are neutral. Okay? You can go ahead and on your own label the 5 parts of the atom, just like we did on the quiz. Go ahead and do that below. And I'll go over the answers here in about 1 minute. Brooklyn? Like measure how wide, like almost like with a ruler, you saying? You could, it's just the units of measurement. It's not inches or centimeters or millimeters, it's like microns or something. So I think they can. It's just very, very, very small. Edgar? Yep. He asked if we labeled the picture there, and I said yes. Oscar? You what? We're going to go over in a minute, but you can label the parts of the atom. So label which one's the proton, electron, neutron, shell, and the nucleus. You have all 5? You have 3. You have all 3 of these, but you need to have the shell and nucleus to keep up. Okay, hopefully you got this correct. So I'm going to go ahead and put the answers up here. The neutron should be the blank particle here. Okay? The proton should be the positive particle in the nucleus. The shell should be the outside rings. Okay? The nucleus is the inside part containing both the protons and the neutrons. And then the electron is down there. Oops, can't see it. Down there. One of the particles on the ring. Micah? Yeah, you can circle it. No, it won't be counted off. No, you can circle it, yes, and then like point to the circle. Yeah. Matthew?
I put more like for the shell. I put a bracket kind of around the entire atom.
That's fine. Chloe? No, point to this part that's actually where it's on the atom. right, number 4. How do you change an atom into an ion? Manny? Very good. Take away or add electrons. It doesn't have to be one or the other. So as long as you change the number of electrons. That's number 4. Change the number of electrons. Yes, Matthew?
I put you add or take away electrons.
Yep, same thing. Ian? If you change the protons, you change the atom altogether. How do you change an atom into an isotope? Amy? Very good. Change the number of neutrons. Aiden, question? Huh? Not yours, but I will give you one exactly like yours, just not one that you've colored on. But we'll get to that in a little bit. Number 6, true or false? Atoms are constantly in motion. Raise your hand if you think true. The parts of the atom are constantly in motion. Raise your hands if you think false. They're just still. And the answer is true. They are constantly in motion. Okay, especially these electrons. They are spinning around all the time. They're not actually still. Number 7, what is an element? Jacob? It is the simplest. Good. That cannot be divided into any other substance. Simplest form of matter that cannot be broken down into simpler substances, right? If we look at an object as an element, we'll see that it's made of many, many atoms, but all of those atoms are the exact same type. Yeah. Can't tell you that. What's coming up? Number 8, when 2 or more elements that are different come together, they form a, Brian? That are different? It forms a kind of molecule, a compound. When 2 or more elements that are different come together, they form a compound. All right, go ahead and try to finish numbers 9 through 12 on your own real quick. I'm going to give you about 2 minutes. Then we'll go over the answers. They should be pretty easy, self-explanatory, but you can do 9 through 12. I recommend either doing it in a pencil or writing small so you can cross it off if wrong. So go ahead and try 9 through 12 on your own. All right, let's talk about the answers. Number 9. When 2 or more atoms are joined together, this is called, Oscar? Maybe, but what do we call just any 2 atoms that bond together? 2 or more. That will automatically make Me ought to have been here for this. Manny? A molecule. Very good. When two or more atoms are joined together, they make a molecule. Number 10, true or false? A compound is always a molecule. Matthew?
True.
That is true. Okay? Remember, I gave you this example. If a molecule is two atoms that come together, okay, a compound is two different elements that come together. Well, elements only exist as atoms, okay? So if two different elements come together, you automatically have two different atoms coming together. Make sense? Now, where's my other little guy? Here he is. Does a molecule always have to be a compound? No. This is an example of a molecule. It's not a compound because both atoms are the same. Yes?
They're electrons. With no nucleus.
Number 11. Who organized the periodic table? Just his last name is fine. Connor? Mendeleev. Dmitri Mendeleev. We'll just spell it right now. Number 12. What are the two main groups in the periodic table? Matthew?
I'm not sure if it's noble gases or not. If it's noble gases or if it's non-metals. But I think it's non-metals and metals.
There you go. Non-metals and metals. Okay. So those are the two main groups. Let's talk about metals for a second first. Number 13. What are some properties of metals? How would we describe elements that are metals? Amy? They are good conductors. Good. What else? Chloe? Aiden? Not all the time. They may be reactive. How do they look? Gold. Yeah, shiny. Good. They're conductive and shiny. Riley? Very good. They have malleability and ductility. Now, they may not be very malleable or very ductile, but they do have some. Also, I want you to make a note to yourself that these are all on the left side of the table, all the metals. Except for hydrogen. He's the only one that doesn't get included in that.